Howdy. Let's talk about congruent figures, like these guys. So, congruent figures, what are they? They have the same size and the same shape. And when two figures are congruent, you can do transformations like shifts or slides, flips or reflections, and rotations or turns so that they will fit right exactly on top of each other. So you can slide, and this figure will just match up perfectly with that figure. We also call that a translation. You can also flip it over. We call that a reflection, like this was the mirror. Just reflected across there. And then a turn, we call those rotations, where you have a point that you're rotating around a certain number of degrees. So, you can determine if two figures are congruent by comparing their corresponding parts. So see how on this figure you have a long side here and a short side here and long side here. The long sides correspond to each other. The short sides correspond to each other. So let's take a look at what a congruent figure is. Congruent polygons have congruent corresponding parts. They're matching sides and angles. So the corresponding parts are their matching sides and angles. And when you name congruent polygons, you list them in corresponding vertices in the same order. So if you got A, B, C, D, A corresponds to E, B corresponds to F, C corresponds to G, and D corresponds to H. So if you call this quadrilateral A, B, C, D, then you have to name this one in the same order of corresponding vertices, E, F, G, H, to say that they're congruent. So if these two polygons are congruent, then we can make all of these conclusions. We can say that segment AB is congruent to segment EF. And you have to say it in that order. You have to say AB is congruent to EF. You can't say that AB is congruent to FE, because F doesn't correspond to A. You have to say them in corresponding points. BC is congruent to FG. CD is congruent to GH, and so forth. Angle A is congruent to angle E. Angle C is congruent to angle G, and so forth. Corresponding parts are congruent. So, let's look at problem 1. If HIKJ is congruent to LMNO, what are the congruent corresponding parts? Well, we can be kind of slick and just say, well, look, remember up here how AB was congruent to EF, and then right here we have AB and EF. If they're listed in the right order, then we can just take it right from here. We can say that HI is congruent to LM. We can do that. So what sides are congruent? We got HI congruent to LM. So that's right here, HI congruent to LM. IJ, if we take the middle two, IJ is congruent to MN. JK is congruent to NO. So JK is congruent to NO. And KH, so KH is congruent to OL. So you can name your sides just based off the names of the vertices. And you can do similar things with the angles. You can say angle H is congruent to angle L, angle I is congruent to angle M, angle J is congruent to angle N, and angle K is congruent to angle O. Bada boom, bada bing. So, pause, see if you got it. Alright, so if triangle WYS is congruent to triangle MKV, what are the congruent corresponding parts? Well, even without drawing it, I could tell you that segment WY is congruent to segment MK, and I can tell you that segment YS is congruent to segment KV, And I can tell you that SW is congruent to VM. So SW is congruent to segment VM. And I can tell you that angle W is congruent to angle M. Angle Y is congruent to angle K. And angle S is congruent to angle V, because those are corresponding parts. So, the wings of an SR-71 Blackbird suggest congruent triangles. What is the measure of angle D? So here's measure of angle D. That's what we want to know. And how are we going to answer that? Well, we know by the triangle sum theorem that the measure of angle A plus 30 plus 75 has to equal 180. So we can find out the measure of A is 75 degrees. And then we can also know that since angle A and angle D are corresponding angles, we know that angle A is congruent to angle D, which tells us that the measure of angle D is 75 degrees. So the answer is B. Okay, so let's see if you've got this. So it might be good to draw these. We could probably do it without drawing, but let's just go ahead and draw them anyway. Let's draw W, Y, S, and let's draw M, K, V. It's important to draw the vertices in corresponding order. W bottom left, Y on the top, S bottom right. That means that the point corresponds to W, which is M, has to also be bottom left. And then the Y is up top, so the K has to be up top. The S is on the bottom right, so the V has to be on the bottom right. Alright, so if the measure of angle W is 62, and the measure of angle Y is 35, then what is the measure of angle V? Well, we can use the triangle sum theorem to figure out S, and since these two triangles are congruent, we know that angle S is congruent to its corresponding angle, angle V. So the measure of angle S equals the measure of angle V. And the measure of angle S is, if you add it to 62 and 35, you get 180 by the triangle sum theorem. Okay, so measure of angle S plus 97 equals 180. Subtract 97 from each side. Measure of angle S equals 83. And then by using the substitution property on this equation, we get that the measure of angle V also equals 83. So are these triangles congruent? Let's see. Let's find out. Let's see. We know that AB is congruent to ED because this little hash mark says they're congruent. That's given to us. BC, segment BC, BC is right here. That's congruent to DC. That's also given to us because 4 equals 4. So definition of congruent segments, they have the same length. AC is congruent to EC. Same deal. So these two are congruent. These two are congruent. Then we got angle A congruent to angle E, and angle B congruent to angle D. Those are all given to us. And angle BCA is congruent to angle DCE. Why is that? Because they are vertical angles and vertical angles are congruent. So here we have all three angles congruent and all three sides congruent. Therefore, by definition of congruent triangles, triangle ABC is congruent to triangle EDC. Okay, let's see if you got it. Pause and see if you can answer this question. Okay, so is triangle ABD congruent to triangle CBD? What do we know? Well, we know that DB, segment DB, is congruent to segment DB. That is the reflexive property of congruence. Do we know about anything about the length of segment AB and the length of segment BC? We don't. We're not given any information about that. We don't know if angle ADB is congruent to angle CDB. We don't know that. All we know is that these two pairs of sides are congruent, and that's not enough information. We don't know anything about angle A or angle C, and we can't even say that this is a right angle because we're not given that. We don't know that for sure. It kind of looks like it, but in geometry you can't ever just say something's true because it looks like it. You have to prove it. And we don't have enough to prove that. We only have enough to say that segment AD is congruent to segment CD. And that segment DB is congruent to itself. That's all we can say. So, can we say they're congruent? No, we can't. Brush fire, that's your secret phrase. So, this is what's called the third angles theorem. This should go with your list of theorems. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if you got two triangles, and they don't have to be the same size, they can just be similar triangles. But if you have two congruent angles, if A is congruent to D and B is congruent to E, then angle C has to be congruent to angle F. And the reason for that comes from the triangle sum theorem. So here's the proof. We're given that angle A is congruent to angle D, and that angle B is congruent to angle E, and we want to prove that angle C is congruent to angle F. So, what do we usually say first? We say the thing that's given to us. So, angle A is congruent to angle D, and angle B is congruent to angle E is given to us. Now what can we say? Well, we can say that the measure of angle A equals the measure of angle D, because that's what congruent angles mean, and that the measure of angle B equals the measure of angle E. And that's just definition of congruent angles. So now we can say that the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180. That's the triangle sum theorem. And then same thing for this triangle. Measure of angle D plus measure of angle E plus measure of angle F has to equal 180. And that is the triangle sum theorem. Well, if we've got this, well, let's see. We know that measure of angle A plus measure of angle B plus measure of angle C has to equal the measure of angle D plus the measure of angle E plus the measure of angle F. Okay, fair enough, because 180 has to equal 180, and that's just substitution property. And then measure of angle D. So here's what we did on this step. Instead of just writing measure of angle A and measure of angle B again, this side over here, they're all the same, right? But over here, we're changing measure of angle A into measure of angle D because we said they're equal right here. So we can use the substitution property to do that. And measure of angle B is equal to measure of angle E, so we can substitute that. So that's just the substitution property. And now we can subtract measure of angle D off of both sides and subtract measure of angle E off of both sides, and we're left with measure of angle C equals measure of angle F, and that's just the subtraction property of equality. And then if their angle measures are equal, that means that the angles are congruent by definition of congruent angles. Q, E to the D. All right, so let's prove that these two triangles are congruent. We're given that segment LM is congruent to segment LO, and that segment MN is congruent to segment ON, that measure that angle M is congruent to angle O, and that angle MLN is congruent to angle OLN. And we need to prove that triangle LMN is congruent to triangle LON. Okay, what do we usually say first? Given. What's given? Well, looks like we're going to start off with talking about segments. So if we can prove that all three segments are congruent, then we're done with the segment part. Then we just have to prove that all three angles are congruent. So we already know that LM is congruent to LO and MN is congruent to ON because that's given to us. Now we can say that LN is congruent to LN. That's the reflexive property of congruence. A segment is congruent to itself. Now we can talk about angles. We got all the sides done. Corresponding sides are all congruent. We're given that angle M is congruent to angle O, and we're given that angle MLN is congruent to angle OLN. And we can now say that MNL is congruent to ONL by the third angles theorem that we just saw. If two triangles have two congruent angles, then the third angles are also congruent. All right, and now we can conclude that the triangles are congruent because of the definition of congruent triangles. They have all congruent corresponding parts. All their corresponding sides are congruent, and corresponding angles are congruent. So, pause and see if you can do this proof, and push play when you want to check. So what we have here is two triangles where we already have corresponding sides, all three of them congruent, and one angle congruent, one corresponding angle congruent. And we want to prove that the triangles are congruent. And in order to do that, we would have to prove that all the corresponding angles are congruent. We've already got all the sides, we just need to finish up with all the angles. So where do we start with a proof? The given information. First, I'll go with all the segments. We're given that segment AE is congruent to segment DC. Got to go in corresponding order, right? AE, DC. Segment EB is congruent to segment CB, and segment BA is congruent to segment BD. So those are all congruent, those are all given. So we've satisfied the side requirements for congruent triangles. Now we need to move on to angles. All right, we also have one pair of congruent angles given to us. We're given that angle A is congruent to angle D. Okay, so where can we go from there? Well, right here we've got vertical angles. So we can say that angle ABE is congruent to angle DBC because vertical angles are congruent. And now we have two triangles with two pairs of corresponding angles congruent, so we can use the third angles theorem to say that angle AEB, or just call it angle E if you want, is congruent to angle DCB by the third angles theorem. Now we have all three corresponding angles congruent, all three corresponding sides congruent, so we can conclude that the triangles are congruent by definition of congruent triangles. All right, there's the end. Talk to you later. Bye.